So in this lesson, we're going to be talking about finding the area of quadrilaterals. Now, in doing this, this is a lesson outside of our textbook. So simply either open this up in your own OneNote notebook and follow along, or get it your notebook and just do it by hand. Follow along for sure. But we're going to talk about finding the area of quadrilaterals. Well, really not just quadrilaterals, but finding the area of different polygons. So let's first break down finding what area is. So area, and we talked about area is, base times height, or we've talked about it being length times width. And remember that area answers are always units squared. And this is a big deal that we have units and that square, that exponent 2, to identify area. It's a space inside a shape. All right. Now, don't confuse that with perimeter, because perimeter here is the distance around a shape, right? So if I were putting up a fence around a pool, the perimeter would be what I am measuring to find what I'm putting the fence, the length of the fence. But if I'm needing to find out how much cover I need to put on top of the pool, or I need to put stone covering the whole space of it, that would be my area, not volume. Don't confuse this with volume. Volume is like the space inside a three-dimensional figure. So let's look at an example here where we are going to find the area of a parallelogram. Now, this is going to be, we'll only look at half of this for right now, right? And so the first one that we're going to look at here is area. Again, we talked about it being base times height, right? And B is our base, and H is the height. And so the base and the height, here's a very, let's not lose our page here, right? This is maybe one of the most important things that you can come from today, is that the base and height always meet at 90 degrees. And we identify the 90-degree mark by being that little square-like shape here. So if I'm finding the area of this, I'm finding my height, right? The height is, the vertical part here, and the base is down here, right? And they meet at this 90-degree space down here. It's extremely also important to recognize that the angle here, oh, that's way too big. Let's bring that down a notch, right? That this slant is not the height, right? Now, if I were looking at this middle figure here, right? I have the base is the bottom of it, right? That kind of matches. But the height before, if you see how the height in the middle here, that's going to be the same as what it is outside of it, right? So if I don't see a height on the inside, it is essentially the same. They will show it to you on the outside out here, but remember, it has to meet at this 90-degree mark. So the height here would be the same if it were in the middle, right? Now, let's get rid of that there, right? Now, if I have the area of a triangle, right? So the area of a triangle is half the base times the height, right? And these are our formulas. These two things are the formulas that we need. And the reasoning why the area of a triangle is half the base and height is because if I were to extend this outward, right? If I were to extend this outward here, if I outline this now as a orange figure, I've created a parallelogram. Sorry, distraction on the outside, right? So I have a parallelogram here. So the base times the height would give me my parallelogram, but if I took half of it, that gives me the triangle. Pretty impressive stuff, because quadrilaterals have angles that add up to 360 degrees, where triangles have angles that add up to be 180. Again, half. Pretty cool. So if I were to look at this and say, well, the base of a parallelogram can be any side of a parallelogram. The height of a parallelogram is the perpendicular distance between opposite bases. And then any side of a triangle can also be the base, right? But the height of the triangle is, again, the perpendicular distance between the base and vertex. Now, if you're not familiar with vertex and what I'm talking about here, vertex is that point of our triangle, right? So if I were to draw a triangle here, right? The vertex, let's get rid of that now, right? So the vertex here is what is perpendicular from the base, and that then creates the height, right? Vertexes are where two lines meet, forming a point here, right? So let's look at an example. So finding the area of this parallelogram. So find the area of the parallelogram. Again, area is base times height. And I'm going to use the visual that they give us here. So find the area of it. Now, here's where we have to remember what makes height, right? I know the base is going to be 8. That's easy, right? Now, the height, which one of these is my height, the 5 inches or the 3.3 inches? Well, hopefully you recognize and remember that the height always meets at a perpendicular point to the base. And so my height would be the 3.3 because it meets at 90 degrees to the base down here. So my height is 3.3. So I'm going to substitute 8 for my base and 3.3 for the height. Now I simply do the computation. I'm multiplying base times height. So 3.3 times 8. 3 and 8 is 24. 4 down, carry the 2. 3 and 8 is 24. Plus 2 is 26. And we talked about multiplying decimals before, where we have one digit. In my problem up here, I have 0 on the 8, so altogether I have to add them. I have 1, so my answer, I need to have one digit, that 4, in my answer to the right of the decimal. So this would be 26.4 square inches. And we could also say that is 26.4 inches squared. All right, so let's look at another example here. Oh, there we are. Trying to get my notes showing up here. All right, so let's look at our next example. All right, well, let's actually do this quick check. So find the area of the parallelogram with 14 as a base and 5 as the height. Well, again, my area is base times height, so I have 14 times 5. So 14 and 5, I'm going to multiply. 4 and 5 is 20, 0 down, carry the 2. 5 and 1 is 5, plus 2 is 7. So this gives me 70, and so I would say that this is 70 meters squared, or I could say 70 square meters. they are the same, right? The way, however I wrote that, they mean the same thing. All right, let's do another one down here, but now we have a triangle, right? So if I have an area of a triangle, and the nice thing with geometry is that we can make it much more visual, right? So let's draw out a triangle, right? And it doesn't say exactly what type of triangle, so I can identify it as any kind right now. So the park of a rectangular plot of land, the triangle has a base of 214 meters and a height of 70. So again, base times height, and I'm going to say 214, and my height, remember my height has to be where it meets at 90 degrees from the vertex, and so that would be 70. So my base, 214 times 70, these I'm substituting 214 for the base and 70 for my height. And so here is where I always start with my formula. So the area of a triangle is 1/2 base times height. And this is where we can choose our own adventure. I can identify, well, half times 214 times 70. Now, some of you guys may identify, oh, half of 214 is 107 because half of 200 would be 100, half of 14 is 7. So I could say, well, this is 107 because I'm taking half of it. And I'm going to multiply that by 70. So you choose your own adventure, and I'm going to then continue multiplying this. Or you might look at this and say, well, 1/2 times 214, it doesn't matter the order I multiply, and say, well, half of 70 is 35. And so 214 times 35. Either way, I'm going to get the same answer. And I could also multiply this straight out and say, well, 214 times 70, and I could multiply that whole thing out, right? So it all depends on what you want to do and what makes sense with your work. But if I'm going to start off with what I started here, because I know that half of 214 is 107, so I'm going to show my work, 107 times 70, zeros across, so I don't need to really do this one. I can just jump to my 7, and I already have my placeholder 0 here. So 7 and 7 is 49. Carry my 4, 7 and 0 is 0, plus 4 is 4, 7 and 1 is 7. So I have 7,490. And that would be 7,490 square meters, or I could have said 7,490 meters squared. Either way, it means the same thing. Alright, so now let's do a little bit of a challenge here. This is where it gets really fun because now we have complex figures, right? So complex figures are simply where I've taken multiple different shapes and now I've created a new figure, right? This is a very irregular polygon. But I can identify that as I'm looking at this, I have 2 rectangles and I have 1 triangle. Because if I look at this, I have a, let's bring this, right? So I have a rectangle over here. Let's bring this up, right? So I can color it, right? So I have a rectangle, and then I have another rectangle here. And then I have my triangle over here, right? So the area of my smaller rectangle, right? Again, base times height is 2 times 5 because I have my base here and my height is 5, right? This 8 that I see here, this is the distance all the way from top to bottom of the entire thing. So 2 times 5 is 10, or I could say it's 10 meters squared. The area of the larger rectangle, well, that is 12 as my base, and now here's where I have to identify, well, what's the height of it? Well, it is 3 because my height is 3. 12 is my base height because it meets at a 90 degree. So 12 and 3 is 36, or I could say 36 meters squared. Now I find the area of the triangle. And my triangle is, well, I have a height here. I see that as 5, right? That's the easy one to identify. But now I need to find what is the base. Well, if I know that this is 2 for the base of this rectangle, 2 plus 6. This right now is 8. And if I had to make that match the entire length of the 12 for what I see down here, 2 plus 6 is 8. So right now this whole space between here is 8. Well, how much more do I need to get to 12? 4. So this would be 1/2 4 times 5. Or I could say 1/2 4 times 5 is 20. So half of 20 is 10. So the total area is, I add up all of these lengths, or all these areas, not lengths, goodness. So the area is 10 plus 36 plus 10, or 10 and 10 is 20. 20 plus 36 is 56. So this would be 56 meters squared. All right, and let's take a look at this last one down here. So our last one is a little bit irregular as well. So a triangle, oh, this has 2 of them here. We'll do a quick one on our triangle, right? So a triangle has a base of 30 meters and a height of 17.3. So again, I always start with my formula. And if I want to say area of a triangle, and I always show that little shape so I don't confuse myself. So area is 1/2 base times height. And if I know that the base is 30 and my height is 17.3, and this is where I have to make sure that I don't confuse myself with those little dots. So if I want to get rid of that dot and just show my parentheses, if I don't see an operation between the parentheses, it means multiplication. So I'm going to simply multiply this straight out, and I'm going to work with smaller numbers. Half of 30 is 15. So 15 times 17.3, 17.3, and 15. I don't have to line up my decimals when I multiply, right? So 5 and 3, they are right above and below each other. So I simply multiply 5 and 3 is 15. 5 down, carry the 1. 5 and 7 is 35, plus 1 is 36. Carry the 3. 5 and 1 is 5, plus 3 is 8. Now I'm done with the 5, so again, I have to make sure I use my placeholder 0. Please use your placeholder 0. Right? That's what this 0 is. So now I multiply 1 and 3 is 3, 1 and 7 is 7, 1 and 1 is 1. I add 5 and 0 is 5, 6 and 3 is 9, 8 and 7, 15, carry the 1, 1 and 1 is 2. So the area of this is 2,595. Oh, I hope you identify and you're like, oh, Mr. K, hold on a second. You multiplied with the decimal here, and there's 1 digit to the right of the decimal in the 17.3. There are 0 and 15, so in my answer, I need to have 1 digit to the right of the decimal. So this would be 259.5 meters squared, or I could say 259.5 square meters. All right. Now let's do our complex figure that we see here. This one gets fun because, well, I identified that I have 2 triangles and I have 1 rectangle, right? So again, we're going to use, and I see my rectangle, I'm going to see that as this right here, and my 2 triangles, I have one right here and I have another one right here. Break it up into shapes that you can easily work with. Right? There is a formula for trapezoids, but rectangles and triangles are a whole lot easier to work with. So let's start off with our rectangle. And so the area of the rectangle, quadrilateral, is base times height. So my base is 4 and the height is 2. So the area is 8 meters squared. Now let's do the area of this blue triangle. Actually, let's do the green triangle first, because I see that I have a area of the triangle is 1/2 base times height. So the base is 4. Don't forget my 1/2 times the height is 2, because they meet at 90 degrees right here. And so 2 and 4 is 8, and half of 8 is 4. So this is 4 meters squared. Now, if I know that for this last triangle, this blue one, this distance here from top to bottom is 4. And if this is 2, that means that this is 2 and that's 2, because these have to be equal to each other in this rectangle. So again, I am doing the exact same equation for this next triangle. Area of the triangle is 1/2 base times height. Base is 2, and my height is, or my base is 4, and my height is 2. And so I have 8, half of 8 is 4 meters squared. I add up each of these lengths, and I end up with, oh, let's write with the color we can see here. So I have 16 meters squared. Alright, so that is it for finding the area of triangles and quadrilaterals and even complex shapes. It's very important, though, that you identify the formula that you're starting with. Area of a parallelogram is base times height. Area of triangles is 1/2 base times height, because if I took a parallelogram and I split it in half, I would have 2 triangles if I look at any of these, right? If I extended this down, I would have a rectangle, which is a parallelogram. So 1/2 base times height is formula for a triangle. Area of a parallelogram, simply base times height. Let me know if you have any questions.